In this video, I'll show you the full build of our new Stork, a 3D printed fixed-wing platform balanced for smooth and efficient flight. With its rear pusher motor, VTEC configuration, the airframe follows a proven and practical layout. It spans 16-20mm from tip to tip with a 1 meter fuselage, placing it right in the mid-size category, large enough for stable cruising, yet still practical to transport. In the description, you will find a link to the project page, where you can access all the details about this design, its geometry, full documentation including the user manual with building instructions, printing tips, a list of recommended electronics and required accessories. Like the other aircraft in our collection, this plane doesn't require a print bed larger than 220 by 220mm. For this build, we used a Bambolab H2S printer with a 340 by 320 by 340mm bead volume. It's a very versatile solution that allows printing much larger projects and supports additional modules such as a laser engraver. You'll also find a link to the H2S printer in the description. As usual, the airframe is printed mainly from low-weight filament. Here you can see PLA Aero with reinforcement parts printed from a rigid material, in this case polycarbonate, which works perfectly for these components. Let's begin the build by preparing the fuselage segments. At the joint locations, you will find the slots for alignment pins, short pieces of raw filament that simply slide into the holes. Then, insert the pins and bond the segments using CA glue. Repeat the process for all fuselage segments. The fuselage itself goes together quickly and without much effort. Before fully closing the fuselage, it's worth reinforcing the front section. Press M3 threaded inserts into the front reinforcement part using a slightly heated soldering iron. This component is responsible for mounting the modular nose. Once it's glued into the front of the fuselage, we can finish assembling it. Next, move on to finishing the fuselage by gluing in the root reinforcement part at the wing to fuselage connection point. Then, install the battery pad in the front section of the fuselage, which is responsible for positioning and securing the battery. Inside the fuselage, also glue in the reinforcement washers at the contact points where the wing mounting nuts will sit. Now let's move on to the hatches, the front and the middle ones. Each hatch consists of two parts, so glue them together the same way as the fuselage segments. Take the hatch lock, which is made of 3 separate printed components. Press the locks into their designated slots and secure them with a small amount of glue along the outer edges. Check the hatch fit, then move on to the wings. Prepare all wing segments along with 6 and 3 mm carbon tubes, each 500 mm long. When gluing the wing segments, slide the tubes into their slots. They will act as alignment guides. Before attaching the wingtip, assemble the aileron by gluing its 2 sections together. Use a 3 mm tube again as an alignment aid. Slide the assembled aileron into position and insert the 3 mm tube into its slot. It works both as a hinge and as additional wing reinforcement. Make sure the aileron moves freely, then glue on the wingtip. Next, install the wing root, just like on the fuselage side, along with the M6 bolts responsible for locking the wing to the fuselage. Here we use M6 bolts printed from polycarbonate with full infill. You can also use ready-made plastic bolts, typically nylon ones. If you don't have access to those, printing them also works well. The next step in wing preparation is installing the servo slot plate. Start by pressing M3 threaded inserts into the designated slots, just like before. Glue the plate into the wing slot. This component provides solid mounting for the servo cover with the aileron servo. This slot is spacious enough to integrate additional electronics, such as an antenna if needed. At this point, set the wing aside and move on to the tail. You will need a carbon tubes of 8, 6 and 3 mm diameter cut to the appropriate lengths. Start by inserting the tube spars into the slots in the fuselage, then glue the stabilizer segments one by one. Just like with the ailerons, glue the rudder vatal halves together and slide them into place. Finally, insert the 3 mm tube into its slot. It serves as both hinge and structural reinforcement. Glue on the V-tail tip. After repeating the process on the other side, the fuselage is complete and ready for electronics installation. Let's return to the wings and install the servos, starting with gluing in the aileron control horns. Mount the servo into the servo cover using the screws included with it. Route the cable through the wing channel, then secure the cover with short M3 screws. Now it's time for the pushrod. There are many possible solutions. Here we're using a 2mm threaded pushrod with a metal snap link on the one side and a Z-band on the other. These pushrods typically come in 200mm lengths, so cut them to match the distance between the servo horn and the control horn. If you're using analog servos, power them beforehand and make sure they're centered before attaching the pushrods. Move to the tail and repeat the same process, starting with gluing in the control horns. Route the servo cable first, then slide the servo into its designated slot. A small amount of hot glue can be added to reinforce the mounting and then secure it using the default screws. Connect the servo horn and control horn using a pushrod. Repeat the process on the other side and all servos in the airplane are ready. Now let's move on to the motor and its mount. In this build, we're using a Brother Hobby 2810 motor with a 10-inch folding propeller. The motor choice is flexible. The motor mount supports 19x19mm or 19x16mm bolt patterns, covering most motors in this size range. The motor mount is also available in step format and can be freely modified for non-standard motors. You can see that M3 threaded inserts are already installed in the 3 mounting points, which will secure the motor inside the fuselage. Start by feeding the motor wires through the channel at the bottom of the fuselage. The wires should be extended beforehand, so they easily reach the central section of the fuselage. Slide the motor into its designated position and secure it with 3 M3 screws. The motor mounting area is reinforced, printed with higher infill and double walls. This segment is also available in step format along with modifiers ready to import into your slicer. Most of the work is now behind us. Let's take a look at the nose. By default, the nose is designed for a standard 19x19 FPV camera with a space for the VTX on a shelf. We also prepared a version for the GM3 gimbal, here shown paired with the Moonlight kit from Cadex. Attach the nose to the fuselage using 4 M3 screws. Next, mount the wings. Insert the main spars, 8 and 10mm carbon tubes, each 1 meter long. Slide the wing into place, route the servo cable and push the wing fully against the fuselage. The mounting bolts pass through the inside. Secure them using printed M6 knobs. If you're using ready-made nylon bolts, nylon nuts can be used instead. At this stage, the entire aircraft is assembled and ready. Of course, the remaining electronics still need to be installed. A simple wiring diagram is available along with a suggested equipment layout. The configuration of the flight controller, GPS and other components is essentially universal for any fixed-wing aircraft. We'll cover this comprehensively in a separate video, using the Stork as an example. That video was supposed to be released earlier, but was delayed. It's now in preparation. We will show you the wiring of essential components, firmware flashing, necessary parameter setup, required calibrations, and all other steps that need to be completed before the first flights. See you in the next video.